Look up on a clear, dark night, and you'll see a spectacular band of stars stretching across the sky. This glowing band, speckled with dark patches and colorful nebulae, is what we call the Milky Way. It's not just a random collection of stars, it's our home, our galaxy. As the seasons change, so does the view of the Milky Way. In the summer, in the northern hemisphere, the Milky Way, from a dark location, far away from city lights, appears as a bright, dense path across the sky, full of stars and nebulae. In winter, it's fainter but still visible if you know where to look. This road of stars, sometimes called the backbone of night, is more than just a beautiful sight, it's the disk of our galaxy viewed from within. But what exactly is the Milky Way? If we could see it from outside, it would look like one of those majestic spiral galaxies you might have seen in photos. A vast disk of stars, containing an estimated 100 to 400 billion stars, about 100,000 light-years across, and only about 1,000 light-years thick, like a cosmic pancake. And just like a pancake, it's flat, with a bulge in the middle where the star density increases. This bulge marks the galaxy's center. Though we can't see our galaxy from the outside, this is how it's perceived based on precise measurements of the movement of nebulae and stars. It's a remarkable image that helps us visualize our home on a galactic scale. We're about 2/3 of the way out from the center, in a minor spiral arm called the Orion-Cygnus arm or just Orion arm. To give you a sense of scale, imagine the Milky Way as a CD. The entire disk of the galaxy is like the diameter of the CD, while its thickness is comparable to the thinness of the CD, a ratio of 100 to 1. In this analogy, our entire solar system would be smaller than a speck of dust on that CD, barely noticeable. Now, consider an estimate of 200 billion stars in the Milky Way. If you were to count each star one by one, at a rate of 1 star per second, it would take you about 6,500 years to finish. Just to count it. That's how vast and populated our galaxy truly is. And our sun, along with all the stars you see in the night sky, is moving around the galactic center, completing one orbit every 230 million years. To put this into perspective, if we imagine that our sun's current revolution around the galaxy is just now completing, it would have begun around the time when dinosaurs first appeared on Earth, and when all the continents were still joined together, forming the supercontinent Pangaea. As for the 100,000 years that light takes to travel across the visible portion of our Milky Way, the sheer scale of this distance is staggering. To put it in perspective, even the fastest spacecraft we have today would take around 185 million years to cross that vast expanse. And if we set course for the center of our galaxy from our current position, it would still take an astonishing 50 million years to reach it. When we look at the Milky Way, we're seeing this disk edge on. The dense concentration of stars we observe is because we're looking through the plane of the galaxy, where most of the stars are. In certain directions, thick clouds of gas and dust block our view, creating those dark patches known as the Great Rift. In contrast, the bright nebulae we see, like the Lagoon Nebula or the Trifid Nebula, are star-forming regions glowing with excitement. Interestingly, there's a region called the Zone of Avoidance, where the dense stars and dust of our galaxy block our view of more distant galaxies. Keep in mind that every individual star you see in the night sky with the naked eye is part of the Milky Way galaxy. However, when we refer to the Milky Way, we're usually talking about this hazy band of light stretching across the sky, the bright core and star-filled plane of our galaxy. The other stars you see, those scattered across the sky outside the luminous band, are in directions where our line of sight looks through the thinner regions of the galaxy, not along the dense length of the galactic disk. To locate the center of the Milky Way, look toward the constellation Sagittarius in the summer sky, just east of the prominent Scorpius. The galactic center lies slightly above and westward of the Teapot asterism in Sagittarius. In the southern hemisphere, this part of the Milky Way arcs high overhead, providing a spectacular view of the galactic core. In the northern hemisphere, it remains lower on the horizon, but its distinct bulge and rich star fields are still visible. The galactic plane, where the majority of the Milky Way's stars are concentrated, is tilted about 60 degrees relative to the plane of Earth's orbit, known as the ecliptic. This inclination causes the galactic plane to stretch as far north as the constellation Cassiopeia and as far south as the constellation Crux. Essentially, our orbit around the Sun is tilted by 60 degrees compared to the plane of our galaxy. The name Milky Way has ancient roots. It comes from the Greek word galaxias, derived from gala, meaning milk. According to Greek mythology, the galaxy was formed when the infant Heracles, who was secretly nursing from the goddess Hera, was suddenly thrown off by the startled goddess. In the chaos, a bit of her milk spilled across the heavens, creating the milky river of light we now see as our galaxy, filled with stars. Standing under the dark sky, with the Milky Way stretching from horizon to horizon, you can't help but feel a profound connection to the cosmos. We are not just observers, we are part of this galaxy, intertwined with its stars, nebulae, and mysteries. The Milky Way isn't just a band of light, it's our home in the vast universe.